welcome along to PMAC Data Engineering Stuff. I'm Paul McComish and I'm a data engineer. And if you, like me, have struggled to find solutions for certain things on the internet or just decent examples of how to use certain things, well, that's why I've created this YouTube channel. Could be focusing on all sorts of things, but today I'm going to focus on something quite niche. I'm going to focus on the Guidewire insurance product, and in particular the cloud data access and how to bring that data into your data platform. So let's have a look. Now we're going to be using the Databricks connector here, and this is the GitHub for the Databricks solution. And if you're familiar with Delta Lake, it works a bit like a shallow clone. You get all the information you need on this GitHub, and you also get the solution and all the relevant source files for it as well. So hop on over to that. That will give you all the information that you need. But how does it work? Let's have a look. Starting off on the Guidewire side, we have in our cloud, or in their cloud, you have your application database. That application database contains all your data, same way as you would if it was on-prem. Now, the CDA product, which stands for Cloud Data Access, is a change data capture feed, which means you get all the inserts, the updates and deletes coming through as an entry through to the data platform. That information comes through and lands on an S3 bucket as Parquet files. Now, these Parquet files are organized into different tables and different timestamp folders and even different schema folders. So there's a particular configuration and setup of how they work. Now, there is a file which contains and controls all of that sort of information. It's called manifest.json. You'll need to know what that is. That contains the information about what tables have been output, where they are located on the S3 bucket, what timestamp versions there are, how many records have been processed, the latest update time, that sort of thing. You'll find all that information in that manifest.json. And we're going to use that information to create a Delta Lake table. What the connector does is read that manifest file, work out where all the Parquet files are, list out the Parquet files, and put them into a Delta Lake log. So we process all our data. We then have what looks a bit like a shallow clone. We have our log files on our Delta Lake on our data platform, but we have Parquet files where the actual data is stored, still sat in the S3 bucket. And you can query that in the same way as you would a Delta Lake table. You can write PySpark, you can write Spark SQL, and you can get access to that data. Then every time you run that connector, it will produce new logs of where that data is, and it will give you up-to-date data. So it's just a case, you could keep it as simple as this, and you could just run the connector every so often, be it once a minute, well, maybe not once a minute, it's maybe a bit too much, maybe once an hour, once a day, once a week, whatever your requirements are and what sort of information you need to get through. So here's a quick demo of how that works. So this is the demo notebook that I've got set up. Our first part is we're going to configure some configurations. So that'll be things like connecting to your S3 bucket. And in my case, Azure, my Azure Data Lake storage account, and where I want to store the Delta Lake logs in that particular path. So we're just going to hit run on there. That will go off and it will do my configurations. I've got some cleanup in there as well from previous demos. So that's all running off in this other notebook I have over here. So we'll just go and let that configure. In the meantime, we'll talk about the code for the Guidewire processor. So the code I've got is actually stored on my workspace in this Guidewire folder. You could, of course, put all this into a Python wheel. No problem with that. In this case, it was just easier as part of our testing. So we have a few configuration options we have on here. So we have our target cloud. In this case, we're talking Microsoft Azure. It could be AWS. And then we've also got a parallel. So we could run these processes in parallel, or we could do this sort of one at a time. Big data stuff, you want to do it in parallel, really. Now, this next one is an interesting one. If you've got lots and lots of tables you're importing, each table will have a subfolder with timestamps on it. So these timestamps can be synced up to be a Delta log. So for each timestamp on the S3 side, you can have a Delta log for that particular folder. And that's fine. You may end up with thousands of these logs, but that's fine. It will just be in the history. But if you change this setting here and change it to false, Then what the process will do is scan all the folders and work out what you haven't already loaded in. And then it will put that into a single version on your Delta log. So rather than having, say, 1,000 logs, 1,000 versions, you could just have all those files you haven't loaded already into one. This next part is table names. Now, you can exclude table names, you can include table names, or if you don't specify it at all, it will just load up whatever's in this CDA manifest file. In this case, just for the purposes of the demo, I'm going to use CC claim, CC activity, and CC vehicle. These are normal claim center tables that are kind of out of the box. And then once you've done your configuration, just a processor.run will run that particular program. So that's now connecting over to my S3 bucket. It's looking at this particular manifest file. And then it's loaded up a widget and it's processing the data through. And you can see the number of folders it's had to process in order to create this particular version. So as I was saying earlier, if you have this setting as true or don't include it, by default, it will create a new version for each one of these folders. So on this initial run, we would have nearly 2,400 versions for CC claim. So that's nearly finished loading. Now we've talked about the manifest file. The manifest file is a JSON document. And if you have a look in the CDA docs from Guidewire, you'll see what it's made up of. In this particular case, because we've limited our read down to these three particular tables, we can just look at the manifest that the Guidewire processor is actually using. So once that's finished loading in, we're just going to run our processor.manifest.manifest. And you can see this is our JSON output, and this is the information that you would get about that particular manifest file for these three tables. So you get useful information like last successful write timestamp. You get the total number of processed records, which is really useful for reconciliation. You have a data files path. So this is the path on the S3 bucket where those files are stored on the Guidewire side. And you also have the schema history. Now, we've only got one schema on this because this is just a development environment. But if you have multiple changes, so you have maybe several different versions of the schema as time goes on and you update and customize your system, you'll see different versions of that schema and a related timestamp folder for those particular schemas. Don't need to worry too much about that. We'll let the Guidewire processor handle all of that, but all that information is available in the manifest. Now I'm going to make use of this. I'm going to create a data frame off that particular JSON. And I'm going to store that in Unity Catalog as a manifest document, as a manifest table, sorry. And that would just bring over those useful bits. And I've got a little conversion here from the epoch timestamp into something a little bit more readable. So we just let that finish writing into Unity. And then what we'll do is we'll do a quick look of that manifest file before we carry on to the next part. And here we have a nice flat table. There we go. So we have our source table, our epoch timestamp, last successful write timestamp, all the same. And we have the human readable equivalent, I guess you call that, and our total processed record count. So that's quite useful. So when we come to reconcile, we've got something to reconcile against. Okay, so you have your data coming through in these log files. You can query it, you can access it. Great. What do we do with it? That's a good question. Well, the most obvious thing to do with it, if you've got Unity Catalog or even a Hive Metastore, create an external table to that particular Delta Lake. You just make it easier to manage, and then it's nice and easy. You just have a straightforward Spark SQL, select star from whatever it is, and you can get that information out of those logs, and you have your nice CDC feed. Now, there is one problem with this. Now, all that data on the S3 bucket will sit there indefinitely. Great, you may think, in data engineer's paradise. Well, not from a data protection point of view. At some point, that data is going to need to be cleared down. Exactly how and when that happens is down to your account manager's control. So you can define, I want to keep 60 days, I want to keep a year's worth. But at some point, you will need to clear some data out from within there. Unless you're in the EU, of course. In the EU, there is a default configuration, and that is set for 14 days. And just for clarification, the UK is no longer in the EU, so we are in the default indefinite. So we don't want to leave it there in somebody else's S3 bucket. We need to bring that data over so we can apply that data retention, and then we can apply our own data retention or masking, whatever it is we have on our side of the data platform. So let's come up with a solution for this. There are different ways that you can do this, and what I'm going to propose is by no means the only way of doing this. And by the time we get to looking at this, you may have come up with other ideas in your head. So we are dealing with Delta Lake tables. Delta Lake tables have version numbers. So we could stream that data in. And this is using the Spark structured streaming processes. And why would we use this? Well, we got checkpoints. We can use those checkpoints to read in that data and work out where we got up to last time. So if we last read up to version 4, we now have version 5 come in, then we just need to read in version 5 and bring that into our managed table. We'll put it as a managed table into Unity Catalog, and then you get all the benefits of having a managed table. And it's as simple as that. It is quite a nice, straightforward stream. Read from the external table, write to a managed table. And that's it. So here's a demo of how that works. So once you've got your Delta logs set up and your Delta tables all configured on your data lake, what do you do with it? Well, that's kind of the next stage. In this particular case, this is just an example approach. You could do all sorts of things. So what we're going to do on here, we have a helper function set up. We're going to create an external table that will point to that Delta Lake location. And this will sit quite happily on Unity Catalog, because you won't be able to use it unless your cluster has got your S3 parameters configured. But assuming you have, you could query this like any other table. We're then going to do something with this. So we're going to create a local version of all the data that sits on the S3 bucket. What we don't want to do is load in data we've already loaded before. So we're going to use some structured streaming and some checkpointing just to make sure we don't load the same thing in twice. So we have a read stream off our table that we just created, nice and straightforward. And then we have a write stream. So format is Delta as usual. We have a checkpoint location, which we're storing on our data lake. We have our merge schema, just because when the data is coming in from our S3 bucket connector, there may be changes to the schema. We want to bring those schema changes in as well. We have a trigger available now equals true. This is there just to make sure this just runs once, rather than a normal stream will just continuously run. We only need this to run the once. And then we have our target table. This will point to a managed table on Unity Catalog. We've given it the same table name, just put an underscore local on the end just to show it's a local version. We also have this await termination in here, and that would just wait for that stream to complete before it moves on and does something else. Now, the reason for putting that in was quite simply to enable us to do some reconciliation as the next step. We haven't built this into the function. This is just a demo. But what you could do is read the manifest table that we just created above and compare that to the number of records that we have in our local version of the table and just make sure that we've brought all the same data over. So that's a simple enough if comparison, but we're not going to do that here. We also have here a loop approach. So we've got a list of all the tables, all the source tables from the manifest table, and we can just do a for each loop. For ease, I've just set up a quick bit of code to just copy in everything for CC activity. Otherwise, we'd have to wait for all of the data to copy over, which can take a little bit of time, depending on how big your starting data is. Obviously, when you do this in a future process, then the data will just carry on from where it left off. So if you started reading at version 5 and you haven't seen anything since version 4, then it would just bring everything from version 5 and everything onwards. And it just keeps it nice and neat. So you're just copying the data that you need. Because CDA is only ever going to be an addition, an append stream, you don't need to keep copying the entire thing every single time. So once it's generated and copied all that data over, we can do a little bit of exploration on the data. So first off, I'm just going to do a quick max update date on our table, which is where all the data is in the S3 bucket. Let's have a look at that one. And hopefully this will give us a date. Yeah, that's given us a date time. And if I do the local copy, so this is what we just copied in using that streaming process, we should have the same. And it looks like we do. And we can have a look at the history as well. So we have a look at the history of that Delta table where all the files on the S3, we have our version. So next time we run our process whereby we use the connector, it will bring in another version. So each time we'll run the connector, it'll bring in the latest version of files. We then do something with it. We then do it again and again and again. So that's the history. And I mentioned reconciliation earlier. So I'm just going to do a quick count on the CC activity table, which sits on the S3 bucket. And I will do a check in the manifest as well, so we can run that. Hopefully both of these numbers will match. There we go. And just to make doubly sure that we've copied it all over, we can do a comparison to the local version. We just put _local on the end. So this is where we just copy that data in. Run that again. There we go. So we have two numbers, one from our managed table in Unity Catalog, and the other one coming from the manifest file. And that's what you want to see. You want to make sure that your numbers add up exactly. So that way, whatever you've ingested from the manifest file is matched exactly the data that you've copied in. Okay, so we now have our managed table. Fantastic. But remember, this is still a CDC stream. You have inserts, you have updates, you have deletes, you have all these entries coming in. And if it's anything like any other product, you'll probably find there's one insert and about 50 updates before it even gets to being deleted. If you even need to delete it, a lot of this stuff will sit there for a while. So depending on how big your platform is, will depend on how complicated that might get. But does it need to be complicated though? Out of the box with Databricks, you have what used to be called DLT. You have declarative pipelines, Lakeflow declarative pipelines. There is a function in there called apply changes, whereby you can apply slowly changing dimension transformations in there. And slowly changing dimensions, just to clarify, a type 1 is where you take those updates and just apply a net result to it all. So basically your table will look pretty much the same as the application table. So if it's inserted, you add a new row. If it's updated, you update that row. If it's deleted, row's gone. The other type is a SCD type 2. Now type 2, many of you will know, but with the declarative pipelines, it will process all of these CDC feeds in order, and you will get the start at and the end at timestamps in there. So every time a row is inserted, that's your new start at, no end at. If the row is updated, you update that end at to be whatever the date is, and you have a new row for the start at. And if it's deleted, it will just stick an end at for you. So that way you can replicate the state of that data at any point in time. And that's what declarative pipelines do for you. It just gives you that information. And if you have a null end at, well, there's your current flag. You could just apply a nice tidy view over the top of that if you want to keep it simple and then more in sync. And that's how easy you could do it. Just run some straightforward declarative pipeline stuff and it processes it all for you. Well, actually, we could make this even simpler. Should we? And this is a debate. Should we do this? Should we take that stream element out and just do a straightforward copy straight through to the SCD table? Pros and cons to that approach. Pro is less copies of the data. Smaller data sets, arguably, particularly if you've got type 1s running. Or the cons, well, if anything goes wrong and you need to rerun this data in for any reason, if it doesn't sit in the S3 bucket and you don't have a copy of it, you only have whatever's in the SCD table. If someone does something screwy with that, you haven't got another way to feed that. So it depends on what your approach is, and it depends on your risk appetite as to whether you want 2 copies of this data, one with all those CDC transactions in, or whether you're just happy going straight through the SCD table. And it's as simple as that. Hope you found that useful. Subscribe and all that jazz, and I'll see you next time.